So in this video, I want to introduce you to finding the gradient of a line, knowing that it goes through 2 points. So let's say we wanted to find the gradient of the line that passes through 2, 1 and 6, 17. Okay, so first of all, it would probably be a good idea to visualize it. So let's draw a diagram of this. So these 2 points, 2, 1 and 6, 17. Now, this point here, with x coordinate 2, y coordinate 1, is going to be to the left of this because that's 6, and below it as well because that's 17. So I can draw that point there as being 2, 1, and 6, 17 will be somewhere here. You know, it's not required to be to scale, so don't worry about that. It's just so you can get an idea that one point is to the right of the other and one point is above the other. So here's the line that goes through those 2 points. And of course the equation of the line would keep going in either direction, but we're just interested in this part of it. So what is the gradient? Well, the gradient is telling you that for every 1 that you travel horizontally, you are going up or down by a certain amount. And that is how we measure the steepness or the gradient of that line. So, for example, if you have a line here, so that for every 1 along, I am going 1 up, then I know that the gradient of that line is 1. And if I had a line that did this, and I knew that for every 1 along, I was actually going up, let's say 3, then the gradient of that line is 3. I don't know how straight that line actually is, but that'll do. So I know that this has gradient 1, and this has gradient 3. So how am I calculating that? Well, the way that the gradient is calculated is by looking at the change in the y-coordinate, so this length here, divided by this length here. So 3 divided by 1 gives me the 3. And in this scenario, the gradient is the y difference, so 1, divided by the horizontal difference, 1. So if I had a line that did this, and I knew that for every 1 I was going up a half, for example, then I know that the gradient is 1/2 divided by 1. Okay? Another example would be looking at something maybe like this, and I knew that for every 3 along, I was going up 2. So how do I calculate the gradient then? Well, I do the same thing. I figure out that distance there, which is 2, and then divide it by that distance there, which is 3. So the gradient in that scenario would be 2/3. So the way that we find our gradient is by working out that distance and dividing it by that distance. Okay? So, let's do that. So this distance here, if we start with that, is going from x is 2 to x equals 6. Okay, so from 2 to 6. So that distance is 6 take away 2, which is 4. So I know that that distance is 4. And from here to here, I know that the y-coordinate of this point is 1. So if you think of that as 1, and then the y-coordinate of this point is 17. So I'm going from 1 to 17. So if I do 17 take away 1, I get 16. don't worry. As I said before, the scaling of my diagram is off. Don't worry about that, okay? It's just so you can figure out what those distances are. So then the gradient of my line is equal to 16 divided by 4. And 16 divided by 4 is 4. So that is the answer to the question. But really what I want to take away from this is some kind of generalized way of working out that gradient. So let's take a step back. What I did to work out the 16 was I did 17 take away 1. And to work out the 4, I did 6 take away 2. So consider the structure here, okay? We have this part here in the top part of your fraction, the numerator, is the difference in the y coordinates. And in the denominator, you have the difference in the x coordinates. So let's take a step back. So we have the difference in the y coordinates divided by the difference in the x coordinates. Okay? When you take this to the next level, you'll be thinking dy over dx. Okay? But I'll leave that as a lingering thought. So if I had two coordinates that were generalized, so let's say I was looking at x1, y1 and x2, y2. So I've got two general coordinates, and they could be whatever coordinates you like. Okay? Then the gradient is the difference in the y coordinates divided by the difference in the x coordinates. Now notice here we have the 17 and then the 6, so it's round that way, and then we've got the 1 and the 2 round that way. So in columns you've got one pair of coordinates, and in columns you've got the other pair of coordinates, okay? Or one column is one and one column is the other. So this is your x1, y1, and this one here is your x2, y2. So I did 17 take away 1, which is the y2 take away the y1, divided by the 6 take away 2, which is the x2 take away x1. So you've got this pair of coordinates, this pair of coordinates. Okay, so they should always match up in columns, and it is this formula that will allow you to work out the gradient. Now you might be wondering, well, did it matter which one I called the x1, y1 and which one I called the x2, y2? Well, actually, no, it doesn't. We'd be in a bit of a pickle if there was a problem here. But let's say I reversed the order, and this was my x1, y1, and this was my x2, y2. Then the gradient would be y2 minus y1, so 1 take away 17, over x2 take away x1, 2 take away 6. So 1 take away 17 is minus 16, and 2 take away 6 is minus 4. Minus 16 divided by minus 4 is 4. So you will still get the same answer, regardless as to which one you call x1, y1, and which one you call x2, y2. So this is how we can calculate the gradient of a line between 2 points.